Good morning, everyone. Today we are going to extend our discussion related to SQL, and we are going to look at few very interesting constructs of select statement. We'll be looking at set operations, then we'll see aggregate functions in SQL, we'll see group by and having clauses. In fact, we have gone through all those operations whenever we discussed relational algebra. Now, the same operations we are going to deal with respect to structured query language. So, let's begin with set operations. The set operations, those we are making use of are union operation, intersect operation and except operation. And these three operations correspond to the relational algebra operations union, intersection and set difference. So except operation is equivalent to relational algebra set difference. So let's see few details about these operations. As these operations are the set operations, these operations automatically eliminate duplicates, if any, in the result. Right? So if we are making use of these operations, there will not be any duplicate tuples in the result. As these are the set operations, automatically the duplicate tuples are being eliminated. But if we want to retain all duplicates, then we are having the additional construct in SQL that corresponds to the multi-set versions. So if we do not want to eliminate duplicates, but we want to retain the duplicates, then we may use this all clause. So union all, intersect all and so on. Right? So this all clause will help us to retain the duplicates. So if required, we may use that. Now, let us see one example. Suppose we want to write a query like find the set of all courses taught either in fall 2009 or in spring 2010 or both. Find the set of all courses taught either in fall 2009 or in spring 2010 or both. So if we want to write this query, obviously we need to split this query in two parts. We have written this query in relational algebra. On the similar lines, we are going to write this query in SQL as well. So first of all, we need to find out the courses those are taught in fall 2009. Similarly, we need to find out the courses those are taught in spring 2010. And what we want to list out the courses those are taught in both these semester years. Means either in this or in spring 2010 or both. So obviously, the set operation to be used is union operation. So we are writing the query, see here, the first part of the query. So this first part of the query will provide us the course IDs from section table which are taught in semester fall and year 2009. Similarly, this query will give us all the course IDs from section relation where semester is spring and year is 2010. And what we want is, we want to have all those courses collectively. So we are making use of this keyword union. We have written this query earlier in relational algebra. So let us try to write that query in relational algebra as well. So we have written this query in relational algebra like projection operation, course ID, selection operation, semester equal to fall and year equal to 2009, and we want to impose this condition on which relation? Section relation. Right? So this will provide me the course IDs from section relation with satisfaction of these predicates. Similarly, we need to write another query that will provide us the course IDs of the courses. Those are taught in spring and year is 2010, and the table once again we are making use of is the section relation, right? And in relational algebra what we did, we wrote these two queries separately and we made use of this union operation. So union operation is equivalent to this keyword union in SQL. So we are making use of here this keyword union. So this will provide us the desired result. As I stated, if I am making use of this union, then if there are any duplicate tuples, then those are being eliminated. Meaning, if a particular course is taught in fall 2009 and also in spring 2010, then that course ID will appear only once in the result. But if we want to retain the duplicates, then we are making use of this construct all. So union all. So this will provide us all the tuples without eliminating the duplicates. Right? Is there any doubt so far? Yes? Let's see how it works in Oracle. So let's try to write the query now. Select course ID from section where semester equal to fall and year equal to 2009. So this is one part. Then union and the other statement. Select course ID from section where semester equal to spring and year equal to 2010. So let's execute it individually first. So if I execute this query individually, what I'll be getting? I'll be getting all the course IDs from section. Those are taught in fall 2009. So there are 3 courses. Okay. Now, if I individually execute this query, then it will provide me the list of courses. Those are taught in semester, spring and year 2010. So these many courses. And if now I make use of this union, then what will happen? Collectively, I will be getting the list of courses. Those are being taught either in fall 2009 or in spring 2010 or both. Right? So we are making use of the set operation union. So if I try to execute this query, I'll be getting the entire list. Now, please see here, we are not having any duplicate courses. So every course appears only once. Right? So if there are any duplicates, those are being eliminated. Now, as I stated, if I want to retain the duplicates, then I'll be making use of this construct union all, right? So see here, right now we are having 8 rows, so 8 courses are being listed in our earlier result, and now if we execute this query by retaining the duplicates, then see here I am having 10 rows in my output. So see here, this course CS319 is repeated, it is duplicated. So in the earlier case, whenever we used only the keyword union, the duplicates were eliminated, but here in union all, we are retaining the duplicates, right? This CS101 also appears twice because it was taught 2 times, maybe in semester fall 2009 and spring 2010 both. So it appears 2 times, right? So I hope you must have understood these constructs union and union all. So let's proceed now with the next query and the next operation. What we want is find the set of all courses taught in the fall 2009 as well as spring 2010. Find the set of all courses taught in the fall 2009 as well as in spring 2010. So how do we write this query? Yes? Anybody who can answer? I want to write this query. So we want to list out the courses those are taught in both these semesters. So what should I do? Which operation to be used?
Intersection.
Intersect operation. Right. So the query remains the same. So we are having, see here, we are having the first part of the query. Select course ID from section where semester equal to fall and year equal to 2009. The other part will also remain same. Only the difference is we are having now this intersect operation. So this intersect operation will provide us only the courses those are available in this set also and in this set also. So common in both these sets. So we are having this intersect operation. Right? Now, if I want to practically execute this statement, then simply what I'll be doing is my statement will remain the same. Only thing is I'll be using intersect keyword, right? And let's see the result. So we'll be visualizing now the course IDs. Those are being taught in both fall 2009 and spring 2010. So only one course is there that is being taught in both these semesters, CS101. Fine. So let's proceed with the next operation. Now suppose we want to find out all courses those are taught in fall 2009 semester but not in spring 2010 semester. Find all courses taught in the fall 2009 semester but not in the spring 2010 semester. We have written this query in relational algebra, if you remember. So whenever we are referring to but not in, that means we need to make use of the operation that is set difference. Right? And we have written this query in relational algebra earlier. Now in SQL, if we want to write this query, we are having the keyword to be used is except in general, except, right? So in many relational DBMS, we are making use of this keyword except, right, to find out this set difference. But in Oracle, typically we are having the keyword minus. So if we are implementing it in Oracle, we need to make use of this keyword minus. But in general, the set difference operation in SQL is executed with this keyword except, right? So let me give you the example how we are going to write it in general. So this query will also remain same, this query will also remain same, and the keyword that we are making use of is except. So this is the general form of SQL. Okay, so select course ID from section where semester equal to 4 and year 2009, except select course ID from section where semester equal to spring and year equal to 2010. So what we are getting out of this is, we are getting all the courses, those are taught in fall 2009, but those are not taught in spring 2010. And we are making use of set difference or this except clause. So as I stated, in SQL in general, the keyword that is being used is except, but if we want to implement it in Oracle, we need to make use of this construct minus instead of this except. Except will not work in Oracle, but in Oracle we are making use of this construct minus to denote the set difference. Okay, so let us try this practically in Oracle now. So let's see the results of individual statements and then we'll try to figure out the final output. So let's try to find out which are the courses those are taught in fall 2009. So have a note of these courses: CS 101, CS 347 and Physics 101. So those are taught in 2009. What we want to find out the courses those are taught in fall 2009 but not in spring 2010, right? So in 2009 we are having courses 101, 347 and Physics 101. Those are taught, 3 courses. So let's see now which are the courses those are taught in spring 2010. So we are having 7 courses. Those are taught in spring 2010. And what we want to find out now the courses those are taught in fall 2009 but not in spring 2010. So in 2009 we had CS 101. So that is also taught in spring 2010. So this will not be there in the result. Okay, CS 315 that was not taught in 2009. So in 2009 we had one CS 101, then 347 and Physics 101, right? So out of this, which are not being taught in spring 2010. So CS 101 is taught, okay, then 347 is not being taught in 2010 and Physics 101 is also not taught in spring 2010. So that should be expected in result. So if we try to execute this statement, we'll be getting these 2 courses, CS 347 and Physics 101. So these courses were taught in fall 2009, but these are not being taught in spring 2010. So this is what the result of set difference operation, and the construct that we are making use of in Oracle is this minus clause. Right? Is there any doubt so far? Yes?
No, ma'am.
May I proceed?
Yes, ma'am.
Fine. So let's proceed now to the next important concept in SQL, and that is aggregate functions. So we have seen these aggregate functions whenever we discussed relational algebra operations. So in SQL also we are having the same 5 aggregate functions. AVG is the function that will provide us the average value. The aggregate function actually operates upon the set of values and provides us a single value out of that. So if I am having the set of values in one single column, suppose salary is the column. So if I am having set of salary values, and if I am using this average operation on this salary column, then what I will be getting is, I will be getting a single value, that is average. Right? So aggregate functions operate upon the set of values typically on a column of a relation, and these aggregate functions will return the aggregated values, the single values, right? So 5 aggregate functions are average, mean, max, sum and count. So average function will provide us average value, mean will provide us minimum value of the set, max will provide us maximum value of the set, sum will provide us sum of values, and count will provide us the number of values, number of elements in the set. So let's see how to use these statements, these functions in SQL. So let us try to find out the average salary of all instructors. What we want? We want to find out the average salary of all instructors. So salary is the column in instructor table. So we need to make use of instructor table and we need to find out the average of the salary column. So simply the select statement that we are making use of is like select average salary from instructor. That's all. Select average salary from instructor, and this statement will provide us a single value, that is the average of salaries of all instructors. If we want to write the relational algebra query for this, how we are going to write it? Yes, we'll be making use of this calibrated G, right, for aggregate function. What we want to find out average salary, and which table to be used? Instructor. So this is the relational algebra query that I may write, right, to find out the average salary of all instructors, and this is the SQL construct. Right? Now let us try one more. If I want to find out the average salary of instructors in the computer science department, I do not want to find out the average salary of all instructors, but I want to find out the average salary of the instructors in the computer science department. So I'll be writing the query like select average salary from instructor where department name is equal to computer science. Select average salary from instructor where department name equal to computer science. So what this statement will do? This statement will first try to find out the tuples where department name is computer science, right? So first of all, what this statement will do is this statement will find tuples such that department name is equal to computer science, and then for those tuples it will operate upon with this aggregate function average. So average will be computed for only the tuples of result of first step. Right? So first of all, if I am having this where clause also in my statement, then what will happen? First of all, on my instructor table, this predicate gets imposed and I'll be getting one temporary relation wherein I'll be having only the tuples for which my department name is computer science. And then out for those many tuples for the new temporary relation, I'll be applying this aggregate function average. Right? So let's try to view these statements. Okay? So what we want is, let us see the first statement. If we want to find out the average salary of instructors, then we'll be writing this statement. Select the aggregate function to be used is AVG, average of salary from instructor. So before that, let's try to visualize the tuples from instructor relation. So we are having instructors, right? And what we want is, we want to find out the average of this salary column, average of all those salaries. So let's try to execute this statement with aggregate function average. So we are getting this average salary. Okay. So a single value is being returned. Right? Now, let me show you a few more statements. Suppose I want to find out the sum of salaries. Then what I'll do? I'll simply use sum of salary from instructor. So this will provide me the sum of salaries of all the instructors. Right? If I want to count the number of instructors, then what I'll do? I'll use select. I may use here star from instructor. So how many instructors we had? 12 instructors, right? So we should get that value. So select count star from instructor and I'll be getting 12. So number of instructors. If I want to find out the minimum and maximum salary of the instructor, then it is possible for me to make use of the aggregate functions mean salary, max salary from instructor. So I'll be getting two columns. This is the minimum salary and this is the maximum salary. Right? I may rename these columns. We have seen how to rename the columns. So if I want to give some other name to this column, then I'll be writing simply see here the name is being changed for the column. So this is the minimum salary and this is the maximum salary of the instructor. Right? Is there any doubt so far? So we have used here all 5 aggregate functions: average, sum, count, mean and max. Any doubt so far? Yes? Any doubts so far?
No, ma'am.
Fine. So now let's try to once again list out the data for all instructors. And now what we want is, we want to find out the average salary. We want to find out the average salary of the instructors from computer science department. So what we should do is, we should impose the condition now. So how we are going to write this statement? We want to compute, no doubt, average salary from instructor where department name is equal to Cont science. Right? So as I stated, what this statement will do, it will first try to find out the tuples from computer science department. So we are having three tuples, 65,000, 75,000 and 92,000. And then average of these three values will be provided. Right? So if we execute this, I'll be getting the average salary like this. Okay? So this is how it is possible for us to find out the desired results. If I want to sum up the salaries of computer science people, then I may use select sum of salary. Correct? If I want to find out the minimum salary for computer science, then I may find out the minimum salary. If I want to find the maximum salary, then I may write the statement accordingly, select max salary, and this is the max salary of computer science people. Right? So simple it is. So I hope you must have understood all those aggregate functions. Let's go to next function. In fact, I have demonstrated this function already. If we want to find out the total number of instructors, then we are going to write the statement like select count in parenthesis star from instructor. Right? It is also possible to include here any attribute, say ID. So I may write the statement like select count in parenthesis ID from instructor. So I may write this statement like select count ID from instructor. So this will also provide me the number of instructors. This will also provide me the number of instructors. Right? Now, let us write one more query. Find the total number of instructors who teach a course in the spring 2010 semester. Find the total number of instructors who teach a course in the spring 2010 semester. So obviously, we need to make use of the relation teaches, because in that relation we are having the data related to which teacher or which instructor is teaching which course in which semester and year. So what we can do is, and what we want to find out the total number of instructors who are teaching the course in spring 2010. So obviously we need to make use of the aggregate function count. Right? And the table to be used is teaches. So how we are going to write this statement? Select count distinct ID from teaches where semester equal to spring and year equal to 2010. So see here, we are not only making use of this count aggregate function, but in parenthesis, instead of writing only this ID, we are writing distinct ID. So why we are having this distinct keyword here? What has been asked for? We want to find out the total number of instructors who teach a course in spring 2010 semester. So it may happen that few of the instructors are teaching more than one courses. Right? So even though the teacher teaches more than one courses, that needs to be counted only once. And that is why we are having here this keyword distinct. So select count distinct ID from teachers where semester equal to spring and year equal to 2010. We have written this query in relational algebra as well, if you remember. So once again, I appeal all of you to relate all those queries in SQL and relational algebra. Right? So that you can have practice of both. Is there any doubt so far? Yes? Is there any doubt so far?
No, ma'am.
So let's see this practically. So what we want to count the number of teachers or instructors. So select distinct ID from teachers where semester is spring and year equal to 2010. So if we execute it, we don't have springs. See here what has happened. The semester is not spelled correctly. Spring we want, right? So let's once again execute this statement. So we are having 6 instructors who are teaching some course in spring 2010. Okay, if I remove this distinct keyword, let's see what happens. I'm getting count as 7. What it indicates, if I'm using count ID, I'm getting the count as 7. And if I'm using distinct ID, then I'll be getting the count as 6. This indicates that one instructor is teaching more than one courses, and that is why it has been counted again. Right? So if we want to count one instructor only once, then we should use here distinct. Got it? Is there any doubt? Yes? Is there any doubt?
No, ma'am.
So let's proceed now. So we have seen aggregate functions. We have seen how aggregate functions can be used with the normal where clause in the statement. And now let's move to a new clause, and that is a group by clause. Group by. So we have seen this group by actually with respect to relational algebra also. Right? And now let us see how group by clause is being used in SQL. So what we want is, we want to find out the average salary in each department. We want to find out the average salary in each department. So the SQL statement that we are making use of is using this clause group by, because we want to group the tuples according to department name, and then for every group we want to find out the average salary separately. statement that we are going to write is, see here, select department name, average salary. We are renaming this column as average salary from instructor, group by department name. I'll repeat, select department name, average salary as average salary. So this is renaming from instructor, group by department name. Now, the important point to be noted here is the attributes in this select clause. So this is my select clause, and in this select clause I am having one aggregate function, average, and other than this aggregate function I am having one single attribute, that is department name. So attributes in this select clause outside this aggregate function must appear in this group by clause. So if we are having select department name comma average salary, so out of this aggregate function I have listed out here the department name, and this department name I should use in my group by clause, because I want to group the data according to department name, and for those individual groups, for those individual departments, I want to find out the average salary. So this is how the syntax of this group by statement. So please remember always that attributes in select clause outside the aggregate function must appear in group by list. If all the attributes other than aggregate function are not appeared in group by, then you will see the error, right? So I hope you must have understood this. Now in Oracle I am going to write this query. I am not making use of this as clause for renaming. Instead I will be simply renaming this column as average salary. So let's try to execute this query in Oracle now. So first of all, let's simply see what we have in instructor table. So we are having these 12 instructors, right? Now, just for the sake of understanding and just to improve the readability, what I'm going to do is, see here, I'm simply ordering my data according to department name. Just for the sake of understanding, see here, what I have done is, I have ordered now my data according to department name, right? So, see here, from biology department, I am having only one instructor. From computer science, I am having 3 instructors. From electrical engineering, 1 instructor. Finance, 2 instructors. History, 2. Music, 1. And physics, 2. And what we want to find out the average salary of the instructors from each department. So average of each department salaries we would like to display, right? If I'm using this statement like select average salary from instructor, what will happen? I'll be getting the average salary, but that will be meant for all the instructors in my table. But now, instead of that, I want to group the data, and for every department, I want to have a separate average value. So, see here how we are going to write this statement. Select department name, comma, average salary from instructor. Let us rename this column average salary as average salary from instructor how we would like to group the data. We want to group the data as per department name. So group by department name, right? So this group by attribute department name must be present here in the select clause outside the aggregate function. That is what the condition is. So we want to group the data by department name. So this department name must be there in this list of select attributes, right? And whatever are the attributes, those are listed in select statement outside this aggregate function, those must be present in my group by class. Now, if I try to execute this, what I'll be expecting? I'll be expecting one entry per department. So how many departments we have? 1, 2, 3, 4, 5, 6, 7 departments. So in output, I'll be expecting 7 rows, 1 per department, along with the average salary of that department. Okay. So let's see the result. See here what we are getting. We are getting 7 rows, 1 row per department, and this is the average salary per department. Right? Is there any doubt? Yes? Is there any doubt? Got the concept? Yes? Got the concept?
Yes, ma'am.
Fine. If I want to display the sum of salary per department, then simply I'll be making use of this sum aggregate function, and I'm grouping my data according to department name. So see here, these are the sum of salaries per department. Correct? So I hope you must have understood this group by clause and how we are grouping the data. Right? May I proceed?
Yes, ma'am.
Yes? Fine. So let's proceed now with one more query. Find the number of instructors in each department who teach a course in the spring 2010 semester. Find the number of instructors in each department who teach a course in the spring 2010 semester. Now, please see here, whenever we find the phrase like each department or department wise, then definitely we need to make use of this group by clause. Right? And what has been asked for? We want to find out the number of instructors. We want to find out the number of instructors in each department with one more predicate, who teach a course in the spring 2010 semester. Right? Now, if we want to write this query, see here how we are going to write this query. Partial query we have written earlier, right? So we have found out the number of instructors who teach some course in spring 2010. But now, instead of having collectively a count, we want to count those teachers department wise. So see here how we are writing the statement. Select department name, count distinct teachers.id as instructor count. So we are renaming this column from, we are making use of two tables, instructor and teachers. So from instructor comma teachers, where instructor ID equal to teachers.id, this is the mandatory condition to match the common attributes if we are using more than one relations in from clause. So this must be there. where instructor.id equal to teachers.id and semester equal to spring and year equal to 2010. Group by department name. Group by department name. So, see here what we are trying to do. We are trying to find out the number of instructors. So, the aggregate function is being used as count. And for every department we want to have that. So, in select statement, the other attribute that we are enclosing is department name. And obviously, this department name should appear in my group by. Right? Now the data is available in these two tables. So we are making use of these two tables. As we are making use of these two tables, this is the mandatory condition for matching the common attribute and the predicate that has been provided in the problem statement. The teacher should teach the course in spring 2010. So we are having these two additional conditions over here. Right? So, in this statement, we are using the where clause with the conditions and also the group by to group the data according to departments. Now, let's see how it works. What we want select department name, comma, count, distinct teachers.id. See here why we are specifically making use of teachers.id, because ID is available in teachers table as well as in instructor table. So we need to specifically mention it, otherwise we'll get the error. So count distinct teachers.id. We want to rename this column as instructor count. From two tables we would like to use instructor, comma, teachers. As we are having these two tables, we need to provide the matching condition where instructor.id is equal to teachers.id and semester equal to spring and equal to 2010. And now we want to group the data according to department name. So group by department name. See here what we are getting. So in spring 2010, 3 instructors from computer science taught some course, 1 instructor from finance, 1 instructor from history department and 1 from music have taught some courses. That is what we have got.
Yes, ma'am.
Fine. So the last construct with respect to this aggregate function and group by clause that we are going to focus upon, and then we'll conclude the session. In fact, whichever are the clauses those we have discussed today, those are really very important to write the queries in SQL. And the next construct that we are making use of is having clause. So this having clause is also being used with aggregate functions and group by construct. Let us try to find out only those departments for which the average salary of the instructors is more than 42,000. See what we want to find out. We want to find out the departments for which the average salary of the instructors is more than 42,000. So obviously, we need to think logically. So what I mean by this, we are having this instructor table, right? And we are having an instructor table, ID, name of the instructor, department name of the instructor, and salary. What has been asked for? We want to find out only those departments for which the average salary of the instructors is more than 42,000. So obviously, if we think logically, what first we need to find out? We need to find out department-wise average salary of the instructors. So we need to first find out department name and average salary for every department. So if I am having department 1, 2, 3, 4 and so on with average salaries, and we know how to compute this using group by. So if we group by our data according to department name, and if we use the aggregate function average salary, then we are getting the data like this, department name and along with the average salary of that department, right? So we have seen this, how to do that. But now what has been asked for, we want to find out only those departments for which the average salary of the instructors is more than 42,000. So suppose this is department, say computer science, and the average salary is suppose something 73,000. Then suppose we are having physics department, average salary is say 40,000, something like that, and so on. So we have grouped the data now according to department name, but we do not want to display all this data. We want to pick only those departments for which the average salary of the instructor is more than 42,000. So we want to put one condition on this aggregated group data. We want to put the condition on this grouped data. So we want to impose the condition, one more condition on the grouped data, grouped aggregated data that we have found out, right? Now, in SQL, to do this, we are having the construct known as having clause. So see here how we are going to write the statement. Select department name, average salary from instructor, group by department name. This is the same statement that we have used to identify this data. And further, after grouping, we want to impose the condition. After grouping, we want to impose the condition. So, to impose the condition after grouping, we are having this new clause here. And this clause is having. So, this having clause is also being used to provide some condition. But this condition is applicable after grouping the data. Please remember, I am emphasizing this concept. This having clause also has the condition, but this condition is being imposed after grouping the data. So we are writing here having average salary than 42,000. So only those departments I'll be visualizing for which the salary is, average salary is greater than 40,000. And to impose this condition, I need to write this statement like having average salary is greater than 42,000. And this having clause appears after group by. So after grouping the data, we are trying to impose upon this condition. So please note that predicates in the having clause are applied after the formation of groups. And if we are having the where clause, which also needs some predicate, then the where clause is being applied before formation of groups. That is a key difference between these two clauses, where versus having. In many interviews, this is a popular question that is being asked. As far as SQL is considered, what is the difference in where clause and in having clause? Because in both these clauses, where and having, we are providing the conditions. Then what is the difference? The difference is the predicates or the conditions. Those are provided in having clause are applied after formation of groups. Whereas the predicates in the where clause are applied before formation of groups. So please keep this in mind, very important. What is the difference in where clause and having clause? Both are using some conditions or the predicates. Having is applied after the formation of groups, and the predicate in where clause is applied before formation of groups. Right? Let us try to execute this statement. So let's write this statement. What we want to find out the average salary according to departments. So select department name, comma, average of salary, rename it as average salary, prompt instructor, group by department name. So see here, we'll execute only this part of the statement. So what we are getting is department name and the average salary. Now what we want only those departments for which the average salary is greater than 42,000. So I think we are having only one department here which is having the less average salary, right? So we will need to have all those departments except this music. Okay, so how we are going to impose now the condition on this grouped data by means of having clause. So group by department name, having average salary that we have already computed, average salary greater than 42,000. If I try to execute this, I'll be getting all the departments except music, because music is having average salary which is 40,000. Got it? So having is applicable after formation of groups, and this having condition is applied on this aggregate function outcome. Got it? Any doubts so far? Yes? Is there any doubt? Have you understood this having clause? Yes? If you have any doubts, please let me know. These are really very important constructs, and you are supposed to practically implement everything in your laboratory sessions for the problem statement that you are having and how to use this having clause to provide the predicate. Now, let us try to have one example wherein we are using both having clause also and where clause also, so that you can identify the difference in a better way. So let us try to write this query. For each course section offered in 2009, find the average total credits of all students enrolled in the section if the section had at least 2 students. Once again, I am reading the statement. For each course section offered in 2009, find the average total credits of all students enrolled in the section if the section had at least 2 students. Now, we want to find out the average of total credits. So, this total credit attribute is available in our student table. So, we need to make use of the student table. What else? We need to make use of another table, that is text, because we are having in text table, we are having the data that which student has enrolled for which section, in which semester, year and so on, right? So referring to our university schema, first of all we need to identify the tables to be used. As we want to find out average of total credits are available in student table, so we need to make use of that table, and which student has enrolled for which section, that data is available in our text table, so we need to make use of that table as well. So how we are going to write this query now? Select course ID, semester, year, section ID and average total credit, average of total credit from two relations, text and student. So the matching condition, the common attribute in text and student is ID. So we are making use of the matching condition text.id equal to student.id, and year that we want to impose upon condition is 2009. So and year equal to 2009. So what we are trying to do here is we are trying to find out the average of total credits of all students, right, who have enrolled in this section in year 2009. But if the section has at least 2 students, then only we would like to do this. So what we need is we need to group the data according to all these attributes. Please look at this. All these attributes, those are outside my aggregate function average. So whichever are the attributes outside my aggregate function, all those attributes I need to make use of in my group by, right? And I want to impose the condition that if the section had at least 2 students, so I need to count the number of students those are enrolled for that particular section in that year and semester, right? So what I need is I need to impose now the having condition on the aggregated data, right? So we are having here the clause having count text.id is greater than or equal to 2. So if minimum 2 students have enrolled for a particular section, then for that section, course, year, right, I want to find out the average credits earned by the students, right? Satisfying first this condition, we are grouping the data according to the course ID, semester, year and section ID, and if more than 2 students or minimum 2 students have enrolled for the course, then and then only we want to find it out. So in having, we are having this condition with the aggregate function count. So if count is greater than or equal to 2, then only we want to visualize this result, or we want to have that tuple in our result. So I hope you must have understood. If you are not having clear understanding, then please once again concentrate. We are going to practically implement this, and if you are having the doubt, you may ask. And once again, I'll emphasize that you should have enough practice to find out the appropriate constructs to be used while providing the SQL statements. So let's try to write this statement: course ID, semester, year, section ID, then average of total credits from two tables we are making use of: text, comma, student. As we are having two tables, we need to have matching condition where text dot id equal to student dot id, and the condition that is being provided in the problem statement, year equal to 2009. Then we want to group the data, so group by. So please remember, in group by I must have all those attributes, otherwise I'll get the error. So group by course ID, semester, year and section ID, and then was the condition on the grouped data. So after grouping, now we are imposing the condition using this having clause, having count text.id is greater than or equal to 2. So if we execute this, we are getting the result: course ID, semester, year, section ID, and average of total credits. Those are earned by the students, and we are finding out this average only if more than two or more students have enrolled for that particular course. Right? So this is what is expected result. So I insist you to once again go through all those statements, right, and try to practice these statements. If you have any doubts, please let me know in due course, right? But the practice is most important. So let's conclude the session today. But before conclusion, I would like to tell you that one important concept that we have not yet touched upon is how to handle null values with respect to aggregate functions. So in the next session, we'll first focus upon that concept, and then we are going for the more advanced constructs in SQL. We'll see the derived relation and how to write more complex queries with clause, right? And also we are going to talk about how to create the views using SQL. So that is what we are going to study in our next session. So let's stop today. Thank you.